So by now it should be pretty clear that I love randomness. The ironic predictability of randomness is what works both in random assignment, which we talked about last week, and in random selection, which we talked about this week. When we do random selection from among a population, we call that probability sampling. And probability sampling is defined by sampling that uses some element of randomness. And there are a number of probability sampling techniques. There's simple random sampling, there's systematic sampling, there's stratified sampling, and there's multi-stage cluster sampling. These are covered in the book in more detail. I'll highlight a few of them and talk a little bit about what they mean. In a simple random sample, you simply take a group of elements that you want to sample from, and you randomly assign a number to them, whether it's through the flip of a coin, heads, tails, or a random number generator, and I can use odds even, or I could create random numbers from 1 to 1,000 and select 1, 10, 20, 30, 40. There's a variety of different ways I can do this, but the key in a simple random sample is that all of the elements have an equal probability of being sampled. Systematic random sampling is a variant of the simple random sample in that we've got a list of people, maybe an alphabetical list at your clinic, and you just take every 10th person on that list. Or you have a list by birth month or something like that. So the key is that if you have a randomized list, if you have a list that's randomly sorted and not systematic, like severity from high to low, you can just take every kth number of person and select those. And that's a systematic random approach, sampling approach. And it's very similar to a simple random sample. What we more commonly see, and this is the answer to the question of what the pollsters do when I describe the problem that pollsters have in using random digit dialing to get a good representative sample of the population, is use a stratified random sample. And in a stratified random sample, I take something like the population of Baltimore. So Baltimore in 2006 had 45% male, 55% female, 65% African American, 32% white, and 3% other ethnicities. And so if I wanted a representative sample of Baltimore, I would sample the population using random digit dialing until I got 65% African Americans, 32% white, and 3% other, 45% men, and 55% women. So pretty soon I would run out of one of those categories. I would get too many of those, and I would stop sampling white folks or African American folks or males or females, depending on which one I got first, until I got a sample that looked just like Baltimore. This is sometimes called proportional or quota sampling because within each of those bins, male, female, African American, white, other, you can use age categories or any categories that are meaningful that you want to sample from. And so I have quotas in each of those, and I need to find a certain amount of people that fit each of those demographic groups. The reason we do this is to avoid the problem I was talking about with those pollsters. So if I just use random digit dialing, the population from which I'm drawing is going to be overwhelmingly female and overwhelmingly elderly. If I want to get a lot of young people, I have to call a lot more people. And so I'm going to be kicking out older people first because I've already gotten enough of them. And I'm going to need to call a lot more people in order to get the younger people in order to represent the full range of political opinions across the age range. So stratified sampling is an important technique. And that's about taking a population that you're interested in, defining certain strata within that population, and then making sure that I've sampled enough of each of those strata. But sometimes I'm also sampling from a large geographic area. So one of the studies that I've used a lot, I use it in my dissertation and some of my articles, is called the National Comorbidity Survey. And they wanted to get a sense of how much mental illness is happening in the population at large across the United States. But they couldn't deal with the whole United States. So what they did is they took units of the United States and randomly selected units. So they worked in Detroit, and they worked in Philadelphia, and they worked in Nebraska, and they worked in Oregon or something like that. So they took regions of the country that were reasonably representative of the nation as a whole. Then within those, they stratified. So they used the strata discussion that we were having before about the right number of people of X age and X ethnicity and X gender. And then within each of those clusters, they sampled the appropriate number of individuals within each of those strata. And that's called cluster or multi-stage random sampling. And in each of these, we take the simple process of randomly selecting people, and we put more and more and more layers on it to refine it. And sometimes we're adding in additional random selection processes. So with the multi-stage sampling, you often are randomly selecting from a larger group of geographic areas, and then dividing it up by strata, and then within each strata, randomly selecting folks. So the key is to take, in some generalizable, representative way, a very large group of people, all people in the United States, break them into smaller units, sample from within those smaller units to make it representative of the population as a whole. However, most of the time when doing work, we're not able to randomly select people for a variety of reasons. It's often not convenient. Often I'm working with a clinic, and they're the ones that have helped me work on some project, and so I'm going to sample from within that clinic. And that's a convenient sample. I'm working with the clinic, so it's convenient to sample from within that clinic. You'll see a lot of studies in psychology are done with undergraduates. It's not because psychologists are super interested in undergraduates. It's because undergraduates are sitting in psychology classrooms, and then the professors can make them do studies for points on for extra credit or whatever mechanisms they use to induce the students to do that. So they're convenient. And so there's a variety of different techniques that we use for non-probability sampling, and they all have problems. They're all going to be less generalizable, more prone to bias, and have a whole host of problems that are less true of the probability samples that we just discussed. However, a lot of times it's just what we have available, and it's where we can get the information from. And so it's not terrible that people have used convenient samples or snowball sampling or the other techniques we're going to talk about. But what is important is that the authors are able to clearly describe what the potential problems with the study are, with the sample are, and how they got the sample, and what they think the limitations of the sample are. And so transparency goes a long way in terms of recognizing some of the problems that arise when you use non-probability sampling techniques. So the first kind of non-probability sampling technique is convenience sampling, and that's the one we've described when we talked about sampling psychology students in a classroom, or me working with a clinic, so I sample from that clinic. When you have an access to a population, it's convenient to use that population for your study. Now, that study is going to be biased. If I use a particular clinic, who that clinic attracts, whether that clinic is cherry-picking the best people, the healthiest people, or maybe my clinic focuses on the least healthy people. And so whatever it is that brings people to that clinic is going to be a potential source of bias. Now, maybe this clinic looks like all of the other clinics in the area, and it just happens to be here and not there, in which case the sample is not going to be terribly biased. But sometimes sometimes convenience is bad. And if you look at psychology studies, we know a whole lot about undergraduates in this country and their psychological states. But it's unclear whether relatively privileged, overwhelmingly white, and in psychology classes overwhelmingly female, 18 to 22-year-olds are representative of all human beings. It's possible that those are just a type of person, and that the psychology of other folks is very different. And so that convenience sample introduces a whole bunch of unknown biases in understanding psychological mechanisms of whatever it is the psychologists are interested in studying. Another type of non-probability sampling technique is called purposeful sampling. So sometimes I want to talk to a particular group of people. I want to talk to people that run clinics. I want to talk to people that use heroin in a particular way, and I go out and I seek those individuals. So sometimes I have a purpose in asking specific questions of very specific people. Now, it limits the generalizability to all other people, but I already know that, right? I'm interested in the opinions of a group of people, and so those are the people, or those are the elements that I'm going to target in my sampling. And a lot of qualitative studies or key informant interviews will use purposeful sampling in order to grab a specific group of people and study those specific groups of people, that specific group of people, and those studies generally aren't looking to be representative, aren't looking to be generalizable to a larger population. They're really interested in a very small, narrow population. Another technique that I've described in terms of non-probability sampling is what I called I didn't come up with it, snowball sampling. Snowball sampling is, as the name implies, you start with one person and you have that person recommend two people, and then you have those people recommend two people, and then you have those people recommend two people, and I've run out of fingers. So you get more and more and more people by having the people you've interviewed recommend other people. It's a great way to get hard-to-know populations. If you're talking to people that are in some particular subgroup, that especially if the subgroup is stigmatized or is considered deviant, sometimes it's the best way to find other individuals that share whatever it is that you're studying. As I mentioned before, when doing studies on qualitative interviews with injection drug users around their heroin use, it's hard to find those folks in just the general population. Random sampling techniques don't work. They're not conveniently arranged. I mean, I guess a convenient sample for that would be to go to a needle exchange program and stand outside and recruit from there. But often what I want to do is find networks of people and utilize that network in order to get information about heroin use. So that's called snowball sampling, and it's a common technique used when investigating populations that are hard to find. The problem with these non-probability sampling techniques is we never know how much or in what direction the bias goes. And so if so for example, when I talked about snowball sampling, and an alternative to snowball sampling heroin users would be to use needle exchange sites as a potential sampling technique. The problem with needle exchange sites is injection drug users that use needle exchange aren't necessarily representative of all injection drug users. So for example, if I'm doing a study on rates of HIV transmission from injection drug use, and I just look at individuals using needle exchange, I'll find a lower rate of HIV transmission than if I looked at the whole population of injection drug users, a lot of whom reuse or share needles, which elevates the risk associated with HIV. So by using a convenience sample, I can often find myself introducing bias into my study that limit the external validity or generalizability of my sample to the population at large. Likewise, snowball sampling doesn't save me from that problem. Sometimes if I get into a network, I'll find particular practices that are practiced within that network. So that network that I investigate might be a network that shares a lot of needles, or it might be a network that has a very strong prohibition against sharing needles. So if I find myself in a particular network and snowball sampling within that network, I can get the idiosyncratic aspects of that network and I'll magnify them to the population at large. That magnification of this idiosyncratic behavior of this network is bias, and it's a form of error that makes it difficult to establish external validity for my study. And that's why these non-random sampling techniques are generally considered inferior to the probability-based random sampling techniques that we discussed earlier. So in summary, a couple of important points. Last week, we talked about the importance of random assignment into treatment and control groups. This week, we talked about random selection from a population into a sample. Uses randomization in both cases, but there are different uses of the term. One is taking one group of people and splitting them into a treatment and a control group. The other is taking a population of interest and sampling from that population. Now you notice they might be stacked, right? I might take a random sample of people from a population and then randomly assign those people to treatment and control. So the purpose of sampling and why we sample is because we want to make some larger statements about a population from a smaller group of people. So we have to sample from that population and in this case we were sampling what the term we used is elements. We're sampling elements from that population, and then we're going to study them, and then we're going to make statements back to the population at large. And that process of moving from the population to the sample and then the sample back to the population is the external validity of the study. Sometimes we call it generalizability. There's lots of ways in which my study sample can be mismatched depending on to my population, depending on how I have sampled from that population into the study sample. And it's important when critically appraising and evaluating studies to think clearly about how they got from the population of interest, all people with depression, injection drug using heroin users, foster care kids, or whoever it is that you're interested in as a population. How did they collect a smaller group of people for the study, and do those people look like the people that are in that population at large? So how related that is the key question for evaluating samples and sample design, and this is also, we use these terms external validity and generalizability.